Hi, good afternoon, everyone. My name is Joe Cava. I'm the Vice President of Global Data Centers at Google. That means that I'm basically responsible for the teams that design, build, and operate our data centers all over the world, from our energy and site selection teams to our IT operations and end of life, so the whole life cycle. I've spent my entire career in either public data centers or in the semiconductor industry, and I've been at Google for a little over 10 years now. And today, I'd like to share with you a little bit of a behind-the-scenes look at what makes Google's data centers unique and why it's so important to me personally to be involved with this organization, and give you a little hint, has something to do with sustainability. Okay, so let's start by first considering, what do you need from your data center? Remember, the whole purpose of a data center is just to support the business. I can't tell you how many times I get asked in conferences like this, what is the best design for my data center? That is an impossible question to answer unless I know what your business is, unless I know what's important to you, what your value system is, how much do you depend on reliability. So, you have to every answer starts with, well, it depends. But with that, there are a few things that I do know that you need. Whether you're in your own enterprise data center or you're in a multi-tenant co-location facility, there are a few common denominators that all of us need. First of all, you need access to high-performance computing available anywhere in the world in which you're doing business. It needs to be highly available, needs to be highly reliable, and it needs to be secure. All of those are the basic core of our data center program. There are core principles at Google, principles around high-performance computing, highly available, highly reliable, and ultra-high security. Since the earliest days at Google, we've been leaders in ultra-high performance computing solutions, and we've done this by a relentless and laser focus on innovation. The high-performance compute that makes up our global network and our global compute infrastructure is really the result of optimizing throughout the entire stack. What I mean by that is that at Google, we design and build our own servers. We write the software and the operating systems that run on these servers. We design and build most of the infrastructure in the data centers. We have custom racks, custom cooling solutions that work with those racks. Our high voltage distribution systems are custom designed for us, and all the way out to the high voltage substations that are on each of our data center properties. These are all designed and optimized across that entire stack with a relentless focus on performance and total cost of ownership. When I first started at Google, it wasn't really obvious to me why Google went to such extraordinary efforts to build their own servers, to design and write all the code that runs those servers, to build all of our own racks and data center infrastructure. Of course, as time went on, it became obvious, but that's an extraordinary effort to go through. And it really became obvious that we had no choice. Long before I got to Google, more than 10 years ago, we had to do our own. We had to design and build our own servers because we just couldn't buy on the commercial market products that met our performance and cost targets. We knew that if things went the way we predicted, even Google wouldn't be able to afford it if we just did things the traditional way. So we had to build our own. We had to write our own software, and it was to allow us to scale at the performance and cost targets that we needed. So all of our servers today are running stripped-down versions of Linux that has been hardened for security. Our servers don't include unnecessary peripherals. They don't have additional chipsets or video cards, things that might add additional vulnerabilities. They certainly add additional costs that we don't need in our compute systems. So we have been relentlessly focused on that performance and cost target since the very earliest days. And this allows us to have a more homogeneous environment so we can dynamically allocate these resources to grow and allocate resources for our customers so that as they grow, they can grow in place with us. And along the way, we've also donated some of what we've learned to the industry. So when we started noticing that the Open Compute program was generating interest in 48-volt DC backplanes for server racks, we donated our reference standards to the Open Compute program. Because we had been doing that with our own 48-volt DC distribution racks for years. We had a lot of experience. So rather than the industry go through all that learning again, we donated the reference standards. And as a result, now, all of our data centers can also accommodate the Open Compute protocol racks if we chose to do that. In each of our data centers, we have our own hardware operations teams. These engineers and technicians are available 24/7. They are the ones that deploy our infrastructure, the ones that upgrade all of our servers. They manage the network. They also repair systems. They're responsible for all of the disk backups. They're responsible for all the disk erase systems. They're doing this 24 hours a day, 7 days a week. We have the technical capability, and we have the capacity to help our customers grow and scale as they need it. And we've also invested a tremendous amount in both hardware and software automation to help these teams be successful and be hyper efficient. This is an example of a fully automated disk erase environment. These robotics enable us to bring disks. You can imagine in a typical Google data center, there's hundreds of thousands of disk drives, millions of them across the fleet. So we can bring disks that need to be erased to this environment, and from there, everything is fully automated, ultra highly secure, ultra high throughput, so that that robot then processes these disks, erases them, verifies that they're erased, or destroys them if they can't be completely verified as wiped. And it gives us much better inventory management in a fully automated environment like this. But our innovation is not limited only to what's on the data center floor. We have had a relentless focus on innovation across all areas of the data center. So one example is in our cooling systems. Over the 10 years that I've been at Google, we have fundamentally redesigned our cooling systems about every 18 months. And we are relentlessly focused on innovation for performance and for cost. Along the way, we've pioneered a lot of water-based technology, such as complete seawater-cooled data center. Data centers that are cooled using rainwater harvesting and gray water systems. Data centers that are cooled using industrial canal water from a shipping canal. So we have gone to pretty extraordinary lengths to try and make our data centers the most efficient for that environment in which they're operating. The point is that we don't have one cookie-cutter-fits-all model. When we go into a new location, we design from a blank sheet of paper with systems that we know will work, systems that are optimized for that local environment. That includes data centers that don't use water cooling whatsoever, like our data center in Ireland, where it's known for its very temperate climate. We use 100% outside air cooled for that data center. Okay, so we've got performance. We know you need that. We know that you need efficiency, but you need data centers in locations that work for you and for your business. This is one of the key differentiators, I believe. At Google, our compute infrastructure is based on 15 global data center campuses. And please understand the word campus. I'll give you an example in a little bit here. But this is not a typical data center where there's one or two data centers. These are very large data center campuses. These are also backed by many, many other public co-location facilities that we also rent. We have over 125 points of presence. Our cloud platform is available in 17 regions, and we have hundreds of thousands of miles of private cable. And including our newest subsea cable system that we just announced, I think yesterday, the DNANT system, that gives us 13 subsea cable systems that we own or share ownership in. So this network that connects all of these data centers is truly one of the biggest differentiators. As a matter of fact, many third parties estimate that upwards of 1/3 of the entire internet traffic is going across Google's network on a daily basis. 1/3 of the global internet traffic. So why have we been investing so much? And if you've been following our earnings announcements, you'll see that we've been investing billions of dollars in building infrastructure for many years. Well, we did it primarily because we had our own services that we had to support globally. We had all of our own users that we had to support. As a matter of fact, Google has 8 products, each with over 1 billion users. This compute and network infrastructure is the same infrastructure that allows us to serve billions of search queries every day in milliseconds. Allows us to serve over 1 billion hours of YouTube video every day. The same infrastructure that allows us to serve and provide storage for over 1 billion active Gmail users. And this is the same infrastructure that our Google Cloud is built upon. Many people ask me, why did you choose to build a data center in XYZ location? Or how do you go about figuring out where you want to build your data centers? And I'll be honest, it is a little bit of an art. It's an art of compromise, because there is no such thing as the ideal place. But there are some tenets that we have in our site selection and location strategy that are time-tested, that work well. One, we want these data center campuses to be in close proximity, low latency, to large user populations. Two, we want to think of this as a long-term investment, so we want to look at what is the TCO for this site going to be over the next decade plus. We also want these campuses to be scalable so that we can continue to grow in place. We want them safe from natural and man-made disasters. We want to employ location-specific designs so that we can design for cost and efficiency. And we prefer to procure renewable energy directly in each of the locations in which we operate. So these are some of the basic tenets that we have when we're doing our site selection. Let me give you an example of just one of our medium-ish data center locations. This one happens to be just outside of Charleston, South Carolina. This is a 200-acre data center campus. As a matter of fact, just the part that's built out that you see right here, this is not all of it, but just the part that's built out. If you were to take a walk around the ring road, around those buildings, that's a 1.5 mile hike. To give you an idea of how big these buildings are, that's the Stanford University football stadium. That's a 60,000 person football stadium. That's one of the buildings on this campus. As a matter of fact, if we were to lay football fields out across the whole 200 acres, we could put 150 of them on this campus. Or another way to think about it, if I took all the servers that are in just one of those data centers and I stacked them all on top of each other, The height of that stack would reach 5,000 feet above the peak of Mount Everest. Okay, so we've covered you need performance, you need efficiency, you need availability, and that comes to you need it 24/7. I've been doing this for a long time, and without exaggeration, I have toured in my career over hundreds of data centers. And regardless of the designs, regardless of where they're built, regardless of the construction companies that built them, can tell you that they're not all created equally, and the reason is because no matter how good the design is, you still have to operate that data center. So with that, we have spent as much energy in our operations teams as we have in our design and construction teams. When we say 7 by 24, we mean 1, forever, and 2, we absolutely mean that. We are relentlessly focused on availability at our data centers. Our basis of design is fault tolerant and concurrently maintainable. What that means is that, look, in electromechanical systems, things break. It happens every day at our scale. Things require maintenance. 1, to prevent failures, and 2, when things break, you have to fix them. All of that should be completely transparent to you, our customers. That's our basis of design, so that something can break and we can be maintaining it and it still is transparent to you. One of our other kind of core beliefs is that we can't predict the future. A few years ago, I would not have been able to predict that we needed liquid cooling at the chips for our latest generation of tensor processing units, the cloud chips that are powering our AI and ML systems. But we do. We have that today. We were able to retrofit our data centers. In fact, it's a little bit like open heart surgery on the data centers, but we were able to do that in live data centers because we think of our designs with an eye towards the future. We build in hooks when we're designing our data centers that allow us to upgrade, that allow us to change the physical infrastructure without having to rip it down and start from scratch. So we're trying to make these future-proof as well. All of our data centers are staffed with Googlers, 7 by 24, and that may seem like a small thing, but I'll tell you, when something happens at a data center, guaranteed it's going to be Sunday night at about 3 in the morning. And you need people on site that are intimately familiar with the designs and the sequence of operations, so they know how best to intervene or how best not to intervene. Sometimes the best solution is to do nothing and allow the systems, the automated systems, to do what they're supposed to do. But if you're not familiar with that design, you weren't the people that commissioned it, you may not know that, you might make an inadvertent mistake. Our teams are staffed with some of the best and the brightest people I believe that we can find anywhere in the world. Most of them have advanced degrees. Many of them come from mission-critical environments, such as the Navy nuclear submarine program. Mistakes on Navy nuclear submarines can be fatal. So those people understand mission-critical. As a matter of fact, we've spent some time analyzing the sources of failures, problems in data centers. And the vast majority, the industry norm is still that the vast majority of incidents is caused by human error. At our GCP data centers, only a small fraction of the incidents were caused by human errors. And of those, none of them in the GCP data centers resulted in any downtime because of the designs, because of the training of our people. It's not good enough to just have smart people that you train. You have to continually drill. You have to test. When you own and operate the data centers, you plan for incidents, you expect incidents, you test for them, and you drill, and you drill, and you drill. That's part of what it takes to operate a cloud. But we have to give our teams a fighting chance to operate these data centers at the availability and performance that we expect. So we have spent a tremendous amount of time and money developing advanced real-time monitoring and control systems. These monitor and control everything from our high-voltage electrical systems to our mechanical cooling systems, to the servers, to the fan speeds, the differential pressures, the leaving air temperatures, the entering air temperatures. To say that Google is obsessed with data is probably a little bit of an understatement. And we use this data and we provide our teams the real-time monitoring and control, everything from chip to chiller, so that we know how to operate and maintain these systems the best. And further, we use the data in machine learning applications so that we can have our AI machine learning systems help us identify better ways to operate the data centers. In fact, give you a little bit of an anecdote in that regard. When we first implemented our machine learning in the data centers for operations, it was a manual system, meaning that the engineers would run the AI or the ML algorithm, and it would spit out recommendations on how to better operate the data center for more efficiency. Over the course of the last few years, as we've been working and perfecting this, it's gotten to the point now that we are rolling out tier 2 automated controls in the data center so that the data centers are optimizing themselves in real time for weather and for load conditions. As the load profile on the workloads of the data center shifts, as the weather patterns shift, the data centers, the ML systems are optimizing the controls in real time. Okay, so we have performance, we have cost, we have location, we have availability, but it probably comes as no surprise to anyone in this room that security is at the top of everyone's mind when we're talking about data center strategy. In fact, CBRE published a paper not so long ago that I was reviewing that at the top of CIOs' minds when they're thinking about their data center strategy, security is number one. And for us, security and data protection are among our primary design criteria. As you all know, data is most vulnerable when it's traversing networks. So Google was the first cloud provider to provide end-to-end encryption of all of our data in transit. In addition, data at rest in the data centers is fully encrypted as well. We use a philosophy of advanced multi-layer security systems. What that means is that the further out you are from the data center, the less secure it is. But the closer you get to the data center and to the network core, the more secure it is, and the more rigorous the scrutiny is of who has access to that data center. We use many advanced technologies, most of which you can see at the data centers, such as video cameras and analytics, perimeter fencing, vehicle barriers, some that you can't see, like laser beam intrusion detection. We use advanced biometric systems that authenticate for access control. We use anti-tailgating devices. So the closer you get to the data center and to the network core, the harder it is to get in there. So it maybe won't come as a surprise to you that only people with a job-related role in the data center ever set foot there. That means that less than 1% of Google's employee population has ever been in one of Google's data centers. This is an example of one of the biometric systems and the circle lock there, the anti-passback, anti-tailgating device. But more importantly, every single person, even though it's so small number of people, every single person that leaves the data center has to go through a full metal detector screening before they're allowed to leave the data center also. The physical security and the logical security have to go hand in hand. And in our data centers, we believe that they are really, truly complementary. We've gone so far as designing our own custom security chips that are in every single server that are monitoring and looking out for bit level access change. So that in addition to all of the physical security, we're also making sure that our team of 800 plus security professionals that are monitoring and managing everything from information security to network security, application security. These are some of the best and the brightest in the entire world, that they're also able to have real-time monitoring to make sure that there's been no bit level change to the applications and to the OS. Okay. What if you had all of this performance available to you around the world, available to you at the price point that you need, and what if you could have sustainability thrown in on top of that? Well, with Google Cloud, you can. For us, sustainability is built on 3 pillars. What that means is that 1, efficient use of resources. 2, renewable energy and zero carbon-based solutions. And 3, the 3rd pillar is built on a circular economy, one and zero waste to landfill, one in which these resources are kept at their most maximum useful part of their life cycle. And I'll get into a little bit more detail about each one of these specifically. I talked a little bit about the AI and machine learning that we have in the data centers. This happens to be one of our small AI pods. We're using our own machine learning algorithms, the same algorithms, by the way, that are available through Google Cloud Platform and the cloud machine learning applications. It's helped us reduce our energy overhead in the data centers by up to 12%. I'll talk a little bit more about that for those that aren't familiar with how we measure energy efficiency in the data centers. But this machine learning has really helped provide insights. Some of the things are not very intuitive. Like, for instance, if you get a low pressure front coming through the plains in Iowa, the weather pattern changes dramatically and quite rapidly. Well, if you just leave the cooling plant running the way it is, you're not operating at the most efficient possible. So we're changing those operating parameters based on real-time feedback from these machine learning algorithms. So the metric that the industry has used for a long time, it's a very simple metric. It's called PUE. It's power usage effectiveness. It's a very simple ratio. The total power consumed in a data center divided by the power that is used for the IT equipment. That ratio gives you a 1.XX or a 2.XX number. Anything above 1 is what we call overhead. So theoretically, 1 would be a perfect operating data center, but that's only theoretically possible because it's not practical. There's always some losses in power transformation, power delivery, lighting, air conditioning, comfort systems, fire life safety systems, office systems. So 1 is really not possible, but you want your number to be as close to 1 as possible. The industry average for almost ever had always been above 2, so that 1 watt of energy was used for non-useful work. The other watt was used for powering the IT systems. That has gotten better over the years, but still, for enterprise data centers, it's still about 60% overhead. For the last 5 years, we have been consistent at only 12% overhead. That's a fleet-wide average on a trailing 12-month basis. Every data center around the world, this is the fleet-wide average. Some of them run much better than that, some run a little bit worse, but the way that we have been able to maintain this, going into some new geographies that have cooling challenges, going and starting new data centers that are not at their peak efficiency because they're not full yet, is through our machine learning algorithms. They've enabled us to save anywhere from 15 to 40% of that overhead term. That has helped us keep at this low level. But so what, you ask? Well, remember, the first pillar of our sustainability is using the resources efficiently. And for us, the best energy saved is the energy not consumed in the first place. That's what we are focused on every day. As a matter of fact, a Google data center uses about only half of the energy of a like-sized traditional enterprise data center. And that same data center today provides more than 3.5 times the compute power as that same data center did only 5 years ago for the same amount of energy consumed. 3.5 times the compute power for the same amount of energy as it was just 5 years ago. You know, last year was a huge milestone for Google. We achieved our 100% renewable energy target in 2017, and we did it about almost 3 years ahead of what target we had set internally for ourselves. What that means is, let me be very clear. That means for all of our data centers, all of the offices around the world, Google's enterprise overall, for every kilowatt hour of energy consumed across the entire enterprise, Google has matched that by purchasing a kilowatt hour of renewable energy from solar or wind projects that were built specifically for Google on our behalf, because we funded the development and we funded the developers by guaranteeing the purchase of that power. That goes to another one of our core beliefs, which is additionality. Buying renewable energy directly from the grid is excellent, it's awesome, and if we had 100% renewable grids, that would be ideal. We don't, and we can't do that today, and we can't do it in some places around the world. So the next best thing is to make sure that we are buying renewable energy to match 100% of our consumption worldwide. And we achieved that in 2017, and we are committed to that going forward. As a matter of fact, Google continues to be the largest corporate purchaser of renewable energy in the world, and by a wide margin. Okay, circular economy. Our core principles are that we want to build our servers from refurbished and remanufactured components as much as possible. We also want to upgrade our servers and redeploy them for other workloads, so that when a server maybe is no longer, or it's met its useful life for search, we can upgrade that server and redeploy it for another workload, maybe logs processing or something like that, so that we don't throw it away. Our objective is to move away, as leaders in industry, to move away from the take, make, and dispose of economy, which is you take natural resources from the earth, you make products, and then you dispose of the products. We want to move to a more circular economy where we're keeping those natural resources in use through upgrade and remanufacture. 75% of our parts are used for refurbs and repairs, and over 2 million units are sold into the secondary market. What that means is that when a disk drive is no longer useful at Google because just the capacity of that disk drive is not what we want to deploy anymore, it still has a useful life, perhaps to someone else. So when that disk drive has been 100% wiped and verified, then we resell that onto the secondary market. Or if a disk drive is beyond repair or has no useful life, then we recycle that through green recyclers. And all these efforts have not gone unnoticed. We, for several years now, have been at the top of the former Carbon Disclosure Program, their A-list rating. I was very proud to, on behalf of Google, accept the Zayed Future Energy Prize from Abu Dhabi in their Abu Dhabi Sustainability Week this last year. And that was, Google was selected amongst 400 global enterprise companies that were nominated by Bloomberg. It wasn't self-nomination. We had no idea that we were even nominated, and yet we were chosen because of our commitment to sustainability and to a circular economy. We've received many ISO certifications for our data centers for efficiency. We were the first cloud provider to achieve ISO 50001 for our energy management system. And many, many other accolades from Greenpeace and Forbes, and the Green Power Leadership Awards. So for us, it's about being leaders in sustainability and paving the way for a new future. For us, it's about when our customers, like for example, when Etsy says that they have a corporate sustainability target and they're using Google Cloud Platform to help them achieve this. For you, it's about knowing that if you're running your workloads on Google Cloud, you can rest assured that those workloads are 100% carbon neutral because of what we're doing. I know that many of you have these same feelings. I'm here to challenge us to let's do this together. Let's build this together. And let's be the leaders of change for this industry. And together we can have that sustainable future in addition to all the other things around performance, around cost, around location, around availability. Let's add sustainability to that, and let's do this together. Let's build this together. Okay. Thank you.